Good morning, everybody. This is the VA PALS Working Group meeting for June 27th, 2018, and it is 10:01 now. Ooh, we're starting late. So anybody else who is going to join us can join us in progress. This is your usual reminder that we are recording this session, and it will be up on YouTube as soon as I get to it, which is usually not that long. And that's it for me. Larry, you were going to do something today, and Rick, did you have something you wanted to say first?
So just a reminder that this week's VA PALS call will not be looking at the user interface. We're going to be focusing on the back end and the architecture. So if you've joined this call to discuss the UI and look at the UI, please join us next week when we will return to our usual pattern. But this week we have some architecture we want to talk about with the community. So it'll be a technical call. And we're going to start with some breakthroughs that we've had in getting our middleware VA PALS server to talk to the Vista server using the M2M broker. So I'm going to hand you over to Larry Carlson, who has been our trailblazer in this area. Larry, you want to take it away? And Linda, you want to give him screen sharing?
Larry has to take his own screen sharing with WebEx.
Okay, share the screen. You can hear me okay?
Yes, we can hear you.
I love that white screen.
Okay. Let me turn my volume clear up. So we thought we would take a quick look at the various M2M broker applications that we're using to update both the graph store and the patient's chart. And so, so we're going to be basically in programmer mode on my screen a lot of the time. So we'll start with taking a look at the graph store. I'm going to set a DFN, which is the, as you all I'm sure know, is the internal entry number of a patient into file 2 in the VA's Vista files. And we're going to go take a look and see what information is in there on this patient. By the way, we can see who the patient is by writing the So we're looking at this patient. And their internal entry number into graph store. Now this is not in Vista. We're now speaking of the graph store global globals, which are kept for use by the forms. And right now, the information in here on this patient is the DFN, the gender, and the name and date of birth. And so one of the M2M broker calls we have pulls some extra information. And we can go back at whatever time that we want to and take a look at how these broker calls work. So M2M is basically it opens up a connection with the other site and then processes data back and forth through XML. So it translates your request into XML on the site, the server. It translates it back from XML and runs through the broker system. And so this takes a while. And so you'll notice there was quite a bit of hesitation there. However, you'll notice now that in the this broker call has brought for us, it's gone over to the server that we were looking at, like the VA, and it has brought back a great deal more information. One of the important pieces being, of course, the ICN. The DFN is how each hospital identifies a patient, the entry number in file 2. But of course, that will be different from hospital to hospital. So the ICN is put together by the master patient index, and that represents the patient nationwide. So we'll write this patient once more, just so that you'll keep us honest here. And I have a CPR-S open, which I hope that you can see with this patient. So here's And is this
Yeah,
over
that's
here?
visible.
Is that visible okay?
Yeah, we're getting the whole wide screen.
Oh, okay. All right. I have a wide screen, and so I was concerned what would. So if I go to the Notes tab, you'll notice this patient right now doesn't have any notes. So I'm going to grab the going to run another M2M broker call here.
What's this one do for us?
And so this one should be generating a new TIU note. There's no text in it yet, but it generates a new TIU note and a corresponding visit. And the working on a solution for this timing problem, M2M, is relatively slow. And as you can imagine, if you've used CPRS, this goes very quickly in CPRS. So if I come back here and refresh patient information, the patient now has a note, and here's the note. There's no text in it, but we have placed a TIU note over on the patient server.
Did you hard code the note title?
Yes, yes. That's a good question. So much of the information here is hard coded and won't be in the future, but for our purposes, I needed to have a title note and some other information, and yes, I have pushed it in manually. But when this is called, when we actually get things set up, I'll be sent the name of a TIU note, a title, and the other information that'll come with it.
Okay, thank you.
Sure. And the TIU note is 84. So I'm going to add a new encounter. And that's what's there right now. This is if you went and looked up the patient's encounter, this is what's in there. It's just the minimal information that basically shows the visit. So let's add some text. By the way, the encounter doesn't show up yet in the in CPRS. There is an encounter stub, but not information. So we're going to add some text, and this is also, by the way, canned to answer the question. So whatever text we send over will be added as a TIU note.
And the pause we're seeing is the M2M broker transmitting from this system to the other Vista system.
Right, and these long pauses are the transmission times through the M2M broker. So there's a couple of things we can do to make it a little faster, but we would have to know who the physician was or the provider was and what his division was. So there's a couple of calls. So let me refresh the information here. And you'll notice now we've pushed over text, and the TIU note now has a note in it. And this is of course just canned information. But we would be sending whatever note was built. So one of the things we were asked to take a look at was whether or not we could add additional signers. And I'm going to copy this. And this is an M2M broker call. Now these broker calls, I should mention, all call existing brokers. All of them actually are part of the CPRS context. So you know, there's a special type of option in file 19. It's called a broker option or a context. And that lists all of the broker calls that the person holding that context is allowed. And it's one form of security or you know, defining the number of broker calls that a person can that a person can use. But we're using broker calls that every VA will have. These came with CPRS and subsequent additions. So you'll notice now we've put additional signatures on here. So there's other cosigners attached to the note as well. And then we want to take a look at the encounter information. So I'm going to run this through again once more just to show you what it looks like in the globals. And then we're going to run this broker call through M to M. So this is from one institution to the other. So as I said, we can mitigate some of this pause, but not all of it. The M2M broker is not built for speed, so it uses brokers that already exist. It goes through a VA, already. Let me refresh the patient information, and now you'll notice the patient has encounter information associated with this TIU note. So the PCE information is there. And see, besides just this, we now have things like diagnosis and health factors added.
Nice.
So the last thing that was, I think the last thing that was requested for TIU notes was to add an addendum. And of course, we can't put an addendum on a note until the note is signed. So I'm going to sign this note. And by the way, if there's any questions, you should interrupt and ask me. So now the note's signed, and now that the note is signed, we'd like to add an addendum. And when you add an addendum, we need to know two things. We need to know the DUZ and the IEN. In other words, we need to know what progress note we want to put the addendum on, and the DUZ of the provider doing it. And my DUZ was already set, but I'm going to put it there so that you can see. And of course, these follow all of the regulations and all of the tasks that fire off on a VISTA side. So, for instance, these additional signers, Dr. King and Dr. Smith, would have gotten alerts saying they have a TIU to sign and when a TIU is done. So all the things that occur normally will be happening as well. So it's just as if it happened through CPRS, because, of course, this is exactly how CPRS does it. Okay, so if I refresh the patient information, you'll notice now that we have the signed note, and we now have an addenda.
Nice.
So there's some ancillary things that are going on in the background. Of course, one is in the forms, when they're filling in the forms, if we're going to add health factors in the, have to know what health factors are available. If you're going to put in reminders, we need a list of reminders. And so all these things need to be stored in GraphStore as well. So I'll run through one. Well, actually, I'll run through two because there's a reason to do it. Now, these are the GraphStore, I call it files. What would they be called? They're globals. I'm not sure what the correct terminology.
It's a graph.
Graphs, of course. So these are the graphs that exist right now. Patient lookup, of course, is, by the way, we've looked at that one before, but patient lookup is built every night. There is a task that can be tasked off on the client side, and that will build a list of all the patients on the server side. But you'll notice right now there isn't a one called health factors. So I'm going to run this. I do that every time when you paste in. And I have a cheat sheet here so that I don't fumble the...
No, it's selected part of the screen again.
All right.
There we go.
By the way, this building of these graphs are also broker calls. So there are broker calls for CPRS, as you can imagine, that brings up health factor, that will bring up health factors, that will bring up reminders when the provider chooses one of those. And so again, these are brokers that exist, should exist out there on every VA server. So we're not don't have to have anything new at all installed on the server side. So now if we run, well, I can upcare it to it. We now have health factors, which is 43. And if we take a look at 43, there's only like a fair number of them here, but so here's all the health factors in the health factors graph. So here's one of the things that can be done to, so I'm going to purge, should have kept track for seconds, but I think you'll find it was about 30 seconds for that last call. So this time I'm going to purge, if there is a graph reminders, it doesn't exist anymore.
Right.
And we will. And these, by the way, are, again, a set that probably should just be run at night. I guess it depends on how often you want reminders updated on the client side, but probably could just be run each evening. So if there are going to be drop downs or selection windows for things like health factors and reminders and providers. By the way, there's also one for providers that we could look at. It basically builds providers on the client side as well. They might be best run in the evening, and in this case, the timing of them probably isn't so important. But some of the things where timing really is more important, of course, are with updating TIU notes and things that should happen much, much more quickly, as they do through CPRS. So is there any interest in looking at the code of one of these to see what you go through? All right. Then I'll show you. So here's the one that builds all connections, and we can take a look at what happens here. First, you have to open a port. And you can set, we have actually a set of parameters on the client side. And the parameters on the client side can be set for what port and what IP address, in other words, what server you're going to. So that needn't be entered again. So this is one of the interesting things that has to happen. And that is with M2M, one has to send the access and verify in readable format to the other site. And that's because it's translated, it'll be encrypted at this side, sent across XML, unencrypted and copied, but it actually is in a readable format. Now we can avoid this by, you can't actually see it in the code because we have it set in in a parameter. But that's one of the disadvantages. And then there's a connect phase, and again we have to run a number of broker calls. So the first one you run is the connect, and it runs through and runs the connect, and it does an XUS sign-on. So it connects to the other site, and it identifies the person and brings back some parameters on that person, just as when you put in your access and verify and sign into CPRS. And then these are a couple that really slow things down a little, but they are unknown the first time. This goes and gets and finds out how many divisions there are, and you know there might well be 2 or 3 or more divisions, perhaps several more at some of the VA sites. So you need to know what divisions exist, and then we do yet another call through M2M that says, and what division is this user signed in at this time? And obviously that makes a difference. You have to be signed into the division with the patient and the information that you want. And then and then of course now it makes another call, and that's the context call. In this case it's in HMP context, but you have to say what context, what option is this user using, which then identifies what broker calls can be used. And so so this is how one runs, and this is why it's as slow as it is. This all happens very quickly. Here's where we actually call the and then we have to finally call the RPC broker call. So this probably warrants a brief description. When you want to go get all patients, there's more than one broker call you can use. One of the convenient calls is the one I'm using, and it's the HMP patient select. This has the advantage that you can put in A, and it will bring back all patients whose last names start with A. And that's what I'm doing up here. These are the ASCII codes for age.
I for A.
I can't say it, but I know what it is. So the trouble is we have to run A, B, C, D, and with each one of these we run this broker call, and this broker call takes about 4 seconds. Processing the information takes no time at all. I mean, in relation, it happens, as far as we're concerned, instantaneously. But this means we have to make 26 calls to bring all the patients back. And there is another call. This is a possible, this is one of the things that we need to do on a new site, on a real site, to take a look at, with a site that has hundreds of thousands of patients, because the broker can time out. So we need to run this and make sure this will run at a site that has a lot of patients before they time us out. We are not lost. There is another broker call where you say what name you want to start with and how many names you want to bring. And you would simply tie it down to what it'll take, and it would slow it down even more, but since it's running at night, it probably doesn't matter. So, and then there's actually setting up the graph in Graph Store, and this happens in in a split second, well, microseconds, very quickly. So this is not a timing issue at all. It's the calls. So even something as simple as going and getting the patient's SSN, we're not doing this one, we're getting it a different way. But even getting a patient's SSN through M2M, if you don't mitigate it by avoiding some of these calls, it's the same thing. You have to go set them up, you have to do a connect, you have to get the division, what division are they in. Now some of this we could perhaps mitigate by the first time they're on saying, what division are you and what division are you signed in on? We wouldn't have to make these 2 calls, and that will knock a few seconds off. Nonetheless, M2M, I've been looking at what makes it slow, and it's the execute phase, and M2M is just a relatively slow communication process. People that are used to using the broker through CPRS or the other applications that call the CPRS broker, the brokers directly, are used to this. They're built for speed. And CPRS does, some other things that we could do if we had to. For instance, when you look up a patient, it looks like it's bringing up the entire hospital's patient list, but it's not. It's bringing up just 100 at a time, but it follows what you type, and you can bring another 100 back very quickly. So you can reduce the speed with some sort of the same things that CPRS does. So anyway, the M2M seems to be working fine. We can create a TIU, add an addendum, put in text, put on additional signers, And thanks to Rick's work, we can also do the encounter. It turns out there was a little problem with encounters, which doesn't require any coding on the server side. It's just that we had well, I think I'll let Rick speak to that and what's coming next. So I think our M2M connectivity appears solid. So if there aren't any questions.
Thank you, Larry. And Phoenix is going to give us an excellent test. They get a lot of patients, so it'll be a good test case for what happens when we're trying to retrieve a large patient file. So our alpha test site is going to exercise this code for us. And that's for those of you who don't know the schedule. Linda and I and hopefully Ardit are flying out to Phoenix, and we'll be there July 12th and 13th. Which is not very far away. It's 2 weeks, more or less, in a few days. And we'll be doing the install. We'll be installing the first draft, the first, test version, shall we say, the first alpha test version of our code at the site by then. So the development teams are all scrambling, and the the project management teams are all likewise scrambling, going, what needs to be in version 1 and what can be put into follow-up patches to make sure that version 1 is a usable but also tested and solid package. So the other thing we wanted to talk about on today's call is the problem that we ran into in Avicenna that Larry alluded to, because it's a problem that can come up on Vista sites, and it is not nearly as well known as other kinds of problems. And if you don't know what it is and you don't understand the code involved, and we're talking about 3 different infrastructure applications being involved in this, then you won't be able to debug it. You'll find yourself having to go line by line through some very difficult abstract code to find out what happened. And what happened ultimately in a nutshell is we are not inside the VA. So there are certain applications that we can't run because those applications are responsible for communicating VHA information to, the Veterans Health Administration data to the Veterans Benefit Systems. And I'm speaking here of the AMI package, AMIE. And here's in a nutshell what was happening. As Larry was testing activities in CPRS and in the M2M broker, he discovered some cases that hung. And in some cases, they seemed to make errors, and in other cases, they just seemed to never finish. And we spent at least a week, maybe a little more, troubleshooting that to figure out what was going on. And ultimately, what it came down to is that the protocol system. Okay, let me do this like a little class. We're going to do this like a little class. How does this all work? When you talk to a Vista server from a CPRS client, like you saw him doing a moment ago, or if you talk to the Vista server with a M2M broker connection, which effectively it's a different processing mechanism, but ultimately it runs the same remote procedures on the server either way. It's just a different way of getting access to them. So what happens then is that you're not talking directly to the application that you think you're talking to. Like if you think you're filing a TIU note, you're not talking directly to TIU. If you think you're doing something with lab, you're not talking directly to lab. Instead, your workstation is talking to a port that's being managed by a Vista infrastructure application called the Remote Procedure Call Broker, the RPC broker. The broker sits there listening, running as an engine, or the Linux system wakes them up. But either way, when you knock on the port and you say, I would like to run this remote procedure, it doesn't give you direct access to the Vista application you think you're talking to. You're talking to the RPC broker, which is an abstract engine whose job is to answer requests for remote procedures and to look them up in the file and to make sure that you have the right security, that you're allowed to run it. And if all is good, then it runs it and takes the output and sends it back across the channel to you. And all of that is taken, although from the user perspective, there is a user present talking to the CPRS GUI, and you'd say, well, of course there's a user present, but not on the other side of the channel, On the other side of the channel, from the Vista server's perspective, there is no user. All there is this message that has come across the channel, and now it must silently, without writing anything to a terminal or to a window, and without reading anything from a terminal or a window, it has to run to completion, get the answer, and send it back as a response message. And the challenge is that a lot of Vista code is written assuming that you have a user present. And some is and some isn't. Some code is silent and can be called, wrapped up in a remote procedure call context and called that way. And a lot of code can't be, because it depends upon the presence of the user. So that's the first thing we've got. You got to think about when you're thinking about how much of the Vista code can you get access to through a mechanism like the M2M broker or like the normal RPC broker that CPRS uses. The first question is, if it's chatty, if it needs there to be a user with a keyboard pressing return or typing answers, it's right out. You can't wrap it up as a broker call. And this is something that's well aware. Vista developers are well aware of this, and in their minds, they're constantly sorting between how much of my functionality have I yet wrapped up in a silent mode that can talk via the broker, that could be useful in the broker, and how much of my code is still kind of trapped in the old 80 by 24 terminal mode, and it should be on my to-do list at some point to come back to that and change it so that it can operate in a silent mode. So the broker is one of the pieces here. Another piece is in Vista, the normal place where silent coding takes place is not the broker per se, it's Task Manager. Task Manager is an infrastructure application that runs silently in the background. It doesn't even have an I/O. It doesn't even have a channel to a client the way that the broker does. Its job is to handle things that don't require user input of any kind, not even in the form of a message. And a tremendous amount of Vista processing takes place in the background being run by Task Manager in little bundles called tasks. Like remote procedures, tasks have to be silent. Unlike remote procedures, tasks are not meant to be called from the outside. So they're utilities, they're helper bodies of code that can be spit off into the background either by an interactive user who might be doing something and say, I want to print a report, and it says, okay, fine, I can run this in the background, and while it's printing, you can go do something else. Or it could be done in the case of a remote procedure call. And the remote procedure starts running, and it says, well, I have a bunch of work to do here, but some of it could run in the background. It doesn't need to finish. I don't care exactly when it finishes. So I'm going to queue that off to run as a task in the background, and meanwhile, I'll finish up what I'm doing and send a response message. So the remote procedure call broker is one of the elements here. Another element here is Task Manager and tasks. The third element that's involved, this was non-trivial to crack. The third element that's involved is the protocol unwinder. And a less gibberish name for the protocol unwinder is, you might think of it as the event manager. So throughout Vista, Vista is modeling the activities of a hospital. Some of those activities are clinically significant, like the moment when a drug is prescribed to somebody, or the moment when an order is placed, or when a result is retrieved. I mean, you can think of these, you think about what are the things in the hospital that are interesting from a clinical perspective, and ideally each of those moments in the processing of the software should pause and say, hey, is anybody interested in the fact that I just prescribed a drug? If you are, I'm going to throw this event, and you can, if you in advance have made yourself a subscriber and written your own code to run at the same time, then it's not just my code that runs. This is a subscriber model. And the intent of it is to make it possible for other applications that are interested in your clinical events to have their code run when those events fire, as well as your code, which is already going to run. These event points are called protocols, using the lingo of the architects of Vista. And the protocol unwinder's job, his job is, whenever you get to a point in the code where something clinically interesting has happened, your application calls the protocol unwinder and says, I want you to fire this event. And as a side effect, if it has any subscribers, I want you to fire them too. And if they have subscribers, fire those too, and so forth, ad infinitum, although not so much infinitum. So these are the three basic pieces that were involved in this bug that we ran into. And the way the bug works is this. The Veterans Benefits Communication application, AMI, which ships, it's installed in Vista at every VA site. It's running at every VA site. And when they wrap up the FOIA and send out a version of Vista to the rest of the world, including to OSEHRA or to World Vista or however you get your hands on it, it's also present. AMI is a subscriber to certain important clinical events. They write their own little events, little subscriber events. And what was the one that we were looking at particularly? Was it scheduling, or was it? Yeah, why don't you share your screen and you can bring this up. So we had a clinical event that was firing as part of the PCE call, I believe, that he was doing. It fired a clinical event, which fired another clinical event, which fired another clinical event, which fired an AMI event, which much to our surprise. Now, because nobody outside the VA has any use for AMI, we can't talk to Veterans Benefits, and Veterans Benefits really could care less what we're doing in our hospitals because we're not VHA. Ideally, what you'd want to do with this AMI, actually, you want to add, SDAM appointment events. This is one of the big event drivers in VISTA, and when things happen involving appointments being placed, appointments being deleted, appointments being updated, a lot of that comes through here. Do you want to add AMI back in here? Should we break this thing on the fly and see if we can?
What was that called? Oh, it was AMI. Just a minute.
So among the people who care when an appointment is made or changed are Veterans Benefits. But VBA wants to keep track of that stuff, but only if you're a VA hospital. So we got shipped, all of you, anybody who has a VISTA system outside of the VA, you got your copy of VISTA and your SDAM appointment events protocol has a subscriber, which is this DVBA CNP SCED event, which is Amy wanting to know, hey, did somebody do something with an appointment? Tell me all about it. But here's our problem. Not all protocols are about firing events. Some protocols are interactive. The protocol unwinder is not only used as the framework for our event handling system in VISTA, it's also used with a user interface system called List Manager. And CPRS and a lot of other VISTA applications use ListMan as their way of presenting options to people. You know, what do you want to do with this patient? Oh, did you want to add something? Did you want to remove something? Is it time to make an appointment? Blah, blah, blah. And all of that is also handled through the protocol unwinder. So the contents of the protocol file include both silent things that it would be safe to run in the background, for example, to run inside of a task that was queued by a remote procedure, and interactive things that are chatty and assume that they're talking over a terminal to a user, and think that they can do things like ask the user to press return to continue. And this is where we got into trouble, because somebody, and I don't know if it was us, but somebody thought, well, nobody outside the VA cares about AMI, so let's just disable this Veterans Benefits protocol. So they went to the disabled field in the protocol file, and they set it to a message that said, hey, you can't talk to Veterans Benefits, you're not the VA, this thing is disabled. And I would have done the same thing, because I would have thought disabled, right? That's how you disable it, you fill in the disabled field. Well, it turns out the disabled field, like a number of other fields like lock and restricted times in the protocol file, is not one of the parts of the protocol unwinder that is capable of running silently in the background. It only works if you're tied to a and there's a user there, because when the protocol unwinder is firing off the SDAM appointment events and it's running through all of its subscribers and firing them, and it gets to the AMI one, it looks in the protocol file and it sees that disabled field. It says, hey, I'm disabled. Instead of silently skipping it, which is what we would really want to have happen in a background task where there's no user, instead, it wrote the disabled message to the screen. Oh, we didn't have a screen. That was a problem. And then it said, press return to continue, and did a read command. It sat there waiting. And the confluence of these actions caused it to get a end-of-file error, because, of course, it didn't have a screen. MUMPS was trying desperately to come up with an error message to make sense out of, you think you're writing to a screen, but there's no screen here, and actually I'm talking over channel. What the hell are you doing? So he called it an end-of-file error, and he crashed with a hard error. That happened to the first task. And I say first because we were in testing mode. We're like, oh, that's weird. It crashed. All right, well, let's go back and try again. But ever after, we were never able to run another one of these tasks. Whenever we would try to make the remote procedure call, and it would queue off the task, and the task would get partway through, and it would fire the SDAM appointment events, it would get to a certain point. The task would never run. It just sort of vanished. Now, what status do we have right now? Have you made this thing a subscriber?
No, I looked. This is what was happening. I just thought I just.
There they are.
So this is what happened.
There they are.
If I'd have made it a subscriber and we'd have tried to process encounters as I had demonstrated,
yes.
Instead, this is what would happen. The encounter wouldn't come, and here we are.
I want you to look at that status message at the end of every one of these tasks. Being prepared. That is a status message that even Taskman, people who think of themselves as Taskman experts, probably find a little unusual. You don't normally see that. You normally see a task scheduled to run at midnight, or it's waiting for a submanager, or it's running, or it's finished, or it crashed with an error, or it's waiting for a device. You don't normally see being prepared, and the reason is being prepared takes microseconds. It takes microseconds. Being prepared is the status when a task submanager, when a task is ready to run, the manager takes it off the schedule list and puts it on the ready to run list, which is the job list. He makes sure that there's plenty of submanagers out there to run tasks. One of the submanagers will grab it off the job list, and when he grabs it off the job list, it's no longer on any of the active lists, so he changes its status to being prepared. And then in a brief window of time, he looks up the task, he sets up the symbol table, he opens the device, he gets everything ready, and then he changes the status to running, right? And then he starts it running. It is a brief window. It is very weird to see a task stuck here. I mean, if the submanager crashed with an error, then he'd say it errored, right? Yeah. If the submanager put it back on the schedule list or on the IO list, it would say it was scheduled or waiting for a device. Or if he started it, it would say run. Or if he rejected it, would say rejected. It is weird to see him caught like this. So what we discovered after we took a few days and troubleshot the submanager to figure out how you ended up in this status. What's going on here? I want you to take a look on the row above being prepared. You see device ORWPX API resource? What's happening is that we have a resource type device here. Resource type devices are a device that unlike anything you think of as you might think of a device as a terminal or a printer, you might think of it as a TCP/IP channel, but all of those are real devices in the sense that MUMPs can open them, MUMPs can use them. When you're done, MUMPs can close them, and as long as you have them open and used, you can write to them and you can read from them. There are these 5 operations that are fundamental to MUMPs. But a resource device, you can't open it, you can't use it, you can't close it, you can't write to it, and you can't read from it. MUMPs doesn't know it exists at all. It is in fact an artifact. It is a kernel knows about it. Our software, Vista software knows about it, but MUMPs doesn't know about it. It's not an actual MUMPs device. It's just a talking stick. It's a trick we came up with in kernel version 7. And the reason we needed this trick was, if you are queuing tasks to run on a printer, they will run in single file. And they will run in strict order. Taskman will make sure that the oldest task runs first, followed by the next oldest, and so forth up to the most recent. In other words, they get in line and they behave well. They single file. But if you have a task that doesn't need a device and you queue it, Taskman's job is to finish as many things as quickly as possible to try to keep up. So he can run all of the non-IO tasks at the same time. He can start up lots of submanagers, and each submanager running in its own job picks up one of these non-IO tasks, and now they're running in parallel. So if it was really important to you that a non-IO task run in order, for example, if you were a banking application and you wanted to make sure that you removed the money from one account before you put it into another, this is the sort of thing you might want to have happen in order, right? As a filing job that doesn't require a device, there was no way in Taskman to keep those tasks in order. So we invented the talking stick, which is the resource device. And you can see them all here. So the way resource devices work is they behave just like any other device as far as Taskman is concerned. If you queue 17 tasks and they don't require a device, they could conceivably all run at the same time. But if you queue them all to a resource device, they will get in single file and run one after another, 1 through 17, in order. Except that there was an exception. And here is the punchline that leads to how things end up being stuck on being prepared. This is mostly a lesson for Vista people who think that they know how Taskman and device learn and all that works, like myself a week ago, who thought I knew how this worked as the author, principal author of Taskman. But I wasn't the exclusive author. Wally Fort's been in here doing work for 20 years. So Wally added something, because what Wally noticed is, if it is really essential that these tasks run in order, then it's not just enough that they're in order. It also has to be the case that if the first task doesn't complete, for example, if it crashes with an error, then all the rest of the ones in line, you don't really want them to run. You want them to stop and wait for somebody to intervene and fix and restart that first task, because otherwise God knows what you're doing to the database. Resource devices, in fact, the whole device model doesn't include that. I mean, yes, if you're queuing a bunch of reports to a printer, they do get in line, but as soon as the first one is done, and I don't mean finished, I mean as soon as it's out of the way, whether it crashed with an error or I forcibly killed the job or it ran to completion, I don't care. Task number 2 is going to start doing his report on the printer. That is the I/O model. So resource devices had that built into it where they don't care what happens to the guy ahead of them. And so in order to fix that, in order to create a new model in which these filing jobs could be not only put in order, but also guaranteed that the second one doesn't run until the first one absolutely completed. And if he crashed with an error, the rest have to wait. He created a new feature in Task Manager called a sync flag for synchronization. Sync flags only work on resource devices. When you queue a task, you have a way to say, I'm queuing it to this resource, and yes, I want to use sync flags. CPRS does that, because CPRS wants its filing jobs to run strictly in order and et cetera, et cetera, et cetera. So the problem is this feature, when it was added, it is a newer feature than the rest of TaskMan. It isn't as mature. It doesn't have as many troubleshooting capabilities as the rest do. And among the things that are missing is there was no status ever created for a task when it tried to reach for the sync flag to say, I should be next in line. Can I go? If the answer was no, the code sort of goes, oh, huh, well, that's unfortunate. So if it can't actually get it, it puts it on a safety net list, which it then doesn't do anything with. They just sit there on a safety net list. And when he moves it to the safety net list, he doesn't change the status anything like, hey, I put this on the safety net list and somebody should come look at this. It just gets left there and being prepared where it was. And nothing is ever going to automatically take it off that safety list. That line waiting for that sync flag is now jammed up eternally until somebody notices that the things aren't running and runs the one option that was added to look at the safety net, look at the sync flag, figure out what's going on, clear the list, and get it running again. There is no automation behind this at all. It is an entirely manual process. So here is the sequence of events, our little domino sequence that led to this. Because we are not a VA site, we tried to run Amy. It didn't. It was to save somebody well-meaning, and I would have made this mistake. So I don't mean this is not a euphemistic insult. Somebody well-meaning disabled the Amy protocol because it makes no sense outside the VA, but unfortunately disabling a protocol and a protocol unwinder causes the protocol unwinder to write to the screen. We didn't have a screen because we were in a silent background task. That caused an error. So the first task in the line for the sync flag died with an error and made it impossible to ever run another task that wanted that same sync flag. They all got dumped into TaskMan's safety net. And there the entire thing just backed up and nothing would ever run again that wanted to that was associated with this task. The only way out of this mess, and thank God this is a development environment, so we don't really care about these tasks, was twofold or threefold. So the first thing we had to do was stop this happening. So the proper solution to fixing SDAM appointment events is not to disable Amy. It is to remove it as a subscriber. You have to go into the list of subscribers and actually delete the Amy protocol off of the item multiple, right? And that's what we did. We deleted it. So that stops creating the problem where this thing is going to write to the screen and cause an error. The second thing that has to happen is we then have to go into file 14.8, and maybe I should... Do
you want me to unstop sharing?
Yeah, why don't I share? Why don't I share here? I'm going to show people how to debug this because this is a problem that can happen. And when I say can happen, I mean the Docker instances that you have right now. If you have copies of the Avicenna via Docker, they have this problem in them, and they will blow up, and they will cause exactly this problem. So I'm trying to, this is why we were taken today for an architecture thing, is I really want to show you this. So I'm going to share my screen, and I'm going to go over to the broker. Here we go. Sorry, not the broker, but to my programming environment. So here's let's go into FileMan. We're going to do the 3 steps right now. So step 1 is let's first do an inquire on the protocol file and look at SDAM appointment events like so. And if you see that what was the name of the DVBA? Okay, so let's first go to the protocol file. What you would see, DVBA CNP. So let's go to the item multiple. So what you would see here is DVBA C and P would be on here. So if you do, I'm going to up arrow out of here. If you do an inquire on the protocol file and you look at no, not that one. You look at SDAM appointment events. You'll want to do this in your own environments, because I think it's not just people who are copying Avicenna. I bet every OSEHRA Vista instance is likely to have this problem, and possibly the World Vista instances, unless they found and removed it. You want to look at this list of items that are subscribing to SDAM appointment events, and if you see DVBA CNP schedule events, then you have this time bomb waiting for you, and you don't want that. So the first thing that you have to do is go into Enter Edit File Entries, go to the protocol file, go to the item multiple, pick SDAM appointment events, select DVBA, and delete them. Right? We're not deleting him from the protocol file as a protocol. We're just deleting him as a subscriber, as an item underneath SDAM appointment events. And you want to double check, make sure that you got that clean. Oops, no, not you. I do that every time. SDAM appointment events. There he is. So we're clear, right? This protocol is now, as they said in Poltergeist, this protocol is clear. So now that that's clear, we have to deal with the two remaining problems, which are that Taskman is in a unfortunate existential state in which he is never going to allow one of these tasks to run, because he knows that the first one in line for that sync flag died, and therefore no other task is ever going to be allowed until the end of time to run on that sync flag. They're all going to stay backed up forever. So the solution to this problem is twofold. First of all, you want to look at file 14.8. This is the task sync flag file. And you see, here is this guy, ORWPX API resource right there. That's saying that this is busy, right? Nobody else is going to be allowed to have the sync flag until that one is done. But that's one that crashed with an error. It will never be done. It's never going to be done. As long as this is here, you can't run any more of these tasks. So again, I'm not telling you what to do with the production environment. That's a whole other thing. If one of your filing jobs crashed, then you got to troubleshoot what did and didn't get done and deal with it before you do what follows. But this is a test environment or a development environment. You don't really care, so you just want to clear this out and get them moving again. So again, enter edit file entries, go to the task sync flag file, and now do a little, well, if you've got like hundreds of them, contact me offline and I'll tell you how to do it, because I want to show you the trick in case you accidentally do it to some file you care about and then you're sad until the end of time. So for now, we'll just say we'll pick the one that's in there, right, ORW, and we'll do an @. Go away, little task sync flag. And now if we do an inquiry on this file, there are 0 entries, right? That was step 2. Step 2 is file 14.8 has been cleared out. So as far as the task sync mechanism knows, nobody is holding this sync flag right now. It's okay for people to run. But there is a final step you have to do, and that's this. %ZTSCH subsync is Task Manager's emergency backup list, safety net. When all else fails, and he expected that he would be able to run a task, but he tried to give it the sync flag and it failed, then he goes, oh. Well, something bad is wrong, and I don't know about these things. I need a human. Human fix me. So that's why the task gets left in being prepared. He goes, I don't know what to do, so I'm just going to make this entry right here, and I'm just going to ignore this task until the end of time. And maybe somebody will think to run the option that looks at this list and does something with it, or maybe they won't because they don't know how sync flags work, and will be jammed up until forever. So you have to get rid of this. And the way you do that is, trust me, as long as this is not a production account, this kill is okay, only without the star and a comma. You want to kill that list, right? Nobody in the safety net, nobody in the sync flag file, and Amy is no longer subscribing to SDAM appointment events. With those 3 changes made, your environment is now clean, and you can run these M2M broker and CPRS calls that result in the firing off of that task. The task will run to completion successfully, as we established. When did we fix this? Day before yesterday? Yesterday? Yes. We fixed it yesterday. So just in time for today's call. So that's the mechanism that you need to follow in order to cleanse your accounts. I know that many people who otherwise know Vista pretty well don't know about this feature because sync flags were added only in the last, only like 10 years ago or something, and not very many Vista applications are using them. And I didn't teach any classes about them, and they aren't very well documented. So this is how you get yourself out of the hole that they will otherwise dig you into. And that explains why you see tasks that say being prepared. That's what's going on. These are resource tasks that have a sync flag, and the first one in the list crashed with an error, and now none of them will ever be allowed to run again until somebody does something. And that somebody better be you. Nobody else is going to fix this for you. So I'm going to wrap that up here and say, for today's call, I think we have shown the things that we had planned to show. So we will stop here for questions, whether questions about the M2M broker or questions about the problem with sync flags that seems to exist in all of these Vista environments outside of the VA. Questions, comments, or concerns? Hearing none, we'll call this a wrap then. Thank you everybody for joining us, and we'll see you next week.